So this is probably the second page of the notes, and it's an example of an expected value problem. So on an expected value problem, it's like trying to figure out how much is this worth? Do you get that we do that almost every day when we're like buying things? You're like, is this worth it? You just don't automatically pay the price for something, you know, like you go to the store and there's a loaf of bread and you're like, okay, I'll buy it, and it turns out to be $87 and you're like, what? It was a loaf of bread, I'm not paying that. You all have to decide what stuff is worth. All right, so when there's probability involved, you have to decide what stuff is worth. I'll give you an example. Would you agree that most people would say that buying the insurance on an iPad, for example, is a judgment call of whether or not it's worth it? They charge you like $100. In fact, all of you guys had to decide that because, you know, you've got an iPad, and I think the school offers a plan, doesn't it? Where if you pay some money, then they'll replace it right away if you break your iPad. I think they do offer that plan. So your parents had to decide, was it worth it or not? What if that plan only cost $1? Well, duh. Free replacement of a cracked screen? Duh. Everybody do it. What if the plan cost $400? No. Way too expensive. I'm not paying that much. So what's it worth? What's it expected? What's the expected value of a warranty like that? All right, please write this down. It's probability times the amount and then add. This, I will explain more later. This is how you figure out what it's worth. The expected value, EV, equals probability. I hope I can assume that P means probability, and you would know that, right? But we probably should write it out. Amount. And usually it's an amount of money. Question?
I can remember.
Yes. If you take your phone out and telling me what you're doing is a very wise idea. Okay. All right, so probability times the amount, and then you add it up. Let's do a really simple one. Let's say that I was going to say, if you will pay me $10, I will let you draw a bill from my wallet and keep it. Now, you might be suspicious just because I'm offering you this deal that it might be a bad deal, right? If I've only got $1 bills in my wallet, then you just got a bad deal. You paid $10 and the best you can get back is 1, right? So your expected value in that case would be 1. You know, the value of a draw, if they're only $1 bills, is $1. But it depends, right, on what's in my wallet. Well, what actually is in my wallet is I do have 2 bills. I have a $50 bill and I have a $10 bill. Now that you know that, would you pay $10 to be able to reach in and grab one of my bills?
Yep.
Yeah, because the worst case scenario is you get 10 back. You can't lose. The other one's a 50. But let's figure out what the actual value of a draw from my wallet is. Is it worth $10? Of course, but it's worth more than $10. Is it smart to play this game if I charge $50?
No.
No, somewhere between 10 and 50 is the fair value. That's the expected value. So we're going to do P times A, and then we're going to add them. What is the probability that you get the $10 bill? I only have 2 bills in my wallet. Okay, so 0.50. We always use decimals. This is a decimal between 0 and 1. Okay, 0.5 times the amount you get if you get my $10 bill. You just don't overthink this. What's the amount you get? 10. You get a $10 bill. No, I know what's fair. What he said is actually 0. It kind of makes sense. You paid $10 to play this, but we factor that in at the end. Okay, so it's worth $10 if you get the $10 bill, and then we're gonna at the end we'll figure out what did it cost and we'll subtract that. Okay, so P times the A, then add it to what? Come on, somebody's be smart enough. Becca, you're smart enough. What's the other?
Add it to the total amount.
Wait. Becca? I said Becca. What do you think the other P times A is? Yeah, so what's the probability of that?
0.5.
Times the amount you get. And then we should add them all up. Everybody grab your calculator, do it, figure out what that game is worth. The probability times the amount, plus the other probability times the other amount. Half of 10 is 5, plus half of 50 is 25. Would you agree that that should add up to 30? Raise your hand if you had 30. Cool. Now, if I played 30 to play that game, then that would have been a completely fair deal. And the expected value, if you pay 30 to play a game that's worth 30, the expected value then becomes 0. Because my expected value was $30, but I did pay I was going to charge you. I didn't actually charge 30 though. I suggested you pay 10, and then you were like, maybe that's a bad deal. But it turns out, if I take my 30 minus the $10 that it costs to play, that's what I suggested at the beginning, then your new expected value would be $20. Do you get that? That means that you should pay to play the game. Because on average, in the long run, you're going to make a lot of money. You get in the first time we play it, you might make money and you might just break even. But then if you keep playing, eventually you're going to get that 50. And eventually, on average, you will make money on this game. All right, do you get that casinos are usually rigged against you? So let's say that this was at a casino. Would they charge you $30 to play this game?
No.
No. What would they charge you? They wouldn't be dumb. They wouldn't charge you like 40 because everybody would be like, well, that's a bad deal. They would seriously charge you $31. Just a little more than what it's worth. So on average, they'll win $1 every time somebody plays. And they get people to play it 1,000 times and they make $1,000. They want it rigged so their expected value is positive. All right, I'll give you another example of this. A casino nearby here, for a while, was trying to get more people to come to the casino. And they figured out that the average person loses $50 every time they come into their casino. The average person walks out $50 poorer. Do you get it's worth paying people to come into your casino? So they were giving away $20 in quarters just to come in. If you'll come in, we'll give you $20. You gotta spend those quarters though. You couldn't just grab the quarters and walk out the door. What they did is they gave you like tokens that only worked in the machines. And so then of course everybody put that in the machine and then be like, I'm out of tokens, I'm gonna buy some more. And then all of a sudden they're sucked in and they might have a new person that is gonna keep coming back. And so they would pay $20 because their expected value then is 30. The average person's going to lose 50. Their expected value was $30 every time somebody came in and said, yeah, I want those $20 in tokens. All right, so expected value comes up in the real world all the time, especially with casinos. All right, let's look at this problem. In your wallet, you have 10 $1 bills. Okay, so the wallet's got a lot more money in it now. 4 $5 bills and 1 $20 bill. Okay, so this is actually, if you look close, these are 5s. And that's a 20. All the other ones are 1s. Now, I'm just going to ask you a dumb question. Would you pay $1 to play that game? Well, yeah, duh. Would you pay $20 to play that game? No. Is there some number in between that would be the fair amount to pay? That's what we're trying to figure out. Would you please do the P times A and then add it all up? P times A, P times A, P times A. Add it all up. Then you'll know the expected value of this game. All right, there's a probability you're going to get one of those $1 bills and then an amount you get if you do get the $1 bill. All right, well, what's the probability of a $1 bill? Well, it looks like there's 10 of them, but It's not 10 out of 10, and it's not 1 out of 10, because there's actually 10, 14, 15 bills you could get. So do you get, there's a 10 in 15 chance you're going to get a 1. Does that make sense to you? Because there's 15 bills, and 10 of them are 1s, so 10 and 15. How much do you get if you get a 1? I know some of you are thinking, but I got to factor in the price of playing the game. Well, was there a price for playing the game yet? Did they say anything about a price? No. If there was a price, we would factor in it only at the very end after we were done. But they don't say any price for playing the game, so it's just $1. Plus the next probability, I think there's a mistake here. Okay, the next probability is the probability of getting a 5, and there are 4 of them out of 15 bills, times you get a $5 if you get a 5. And the last probability is that $20 bill is 1 out of 15 of those, and that's worth 20 if you get it. If you do probability times the amount, and then you add them all up, you will have the answer. If you were doing it right so far, and you actually have a final answer, would you please raise your hand? Mr. Albright, what did you get?
9.26 around there.
Can anybody verify it would round to around 926? Oh, nope, different answer. Now, I know you are a smart kid. That is probably because you messed up the fractions. If you put parentheses around all of these and typed it in exactly the way you see it, with parentheses, it'll do it right. It's easy to forget the parentheses. And if you don't do the parentheses, it's likely it's going to screw it up. So I'm going to type this in exactly as I see it with the parentheses. And you do it too, please. And give me what you think your best answer is. Do I have to say times 1? No, I'm not going to say times 1. Okay, he's got a new answer. Give me just a second. I want to get my new answer.
It's close. It's around
$3.
$3. 3-4.
Oh, we did decimal places, that's why. Yeah. 3.2.
I got a decimal that's 3 point something. Raise your hand if you got the same thing. Okay, good. I got 3.3 repeating, which if it's money is going to be 333. Raise your hand if you got the same thing as me. Okay, cool. Now, I kind of typed this in with all the parentheses, but do you really need a parenthesis around a single 5? No, that's kind of dumb. Do you really need parentheses around the 4/15? Yeah, you kind of do. Otherwise, you're going to screw up the order of operations. Okay, so just include the parentheses around the fractions, but not around the whole numbers. There's no difference between parenthesis 20 and just 20. Okay? All right. So if you didn't get 333, you got to learn how to get that in there right because you're not typing them right. Okay. Now let's say they charge you $3 to play this game. Should you play the game if your expected value was 333? Well, should you play the game? For some people, you just don't gamble, and therefore you're never going to do it. And I get it. And that's good. It's smart not to gamble. But if this is a business situation, and your business is deciding whether to buy this insurance, and on the average they think it's worth $333, and the price is $3, is it a smart business decision then to buy the insurance? And remember, when you're a big company, we're not talking dollars. These are in millions. Do you get that you might have to buy insurance for something, and it might be worth this much, and the cost is this much? Then you might be like, yeah, we should buy that insurance because it's coming out positive. If it comes out positive at all, even if it's 33 cents positive, then that means, times it by a million, all of a sudden, that's $333,000 you just saved your company. See what I'm saying? So if it comes out positive, the answer is yes, you should do it. Okay, it came out positive, so yes, you should do it. Would a casino charge you $3 to play this game? No, they would charge you more than that. They might charge you $4 to play the game. It's only worth $3.33. They're going to make 77 cents every time you play, which is a real thing. Like, they'd happily do that all day long. If they can make 77 cents on a bet and you keep doing it over and over and over again, it's like a buck. They'll make lots of money on it. And that's how it works in a casino. They don't make tons of money every time you bet. They make a little bit on average. Okay. Go to this page. It's a spinner. We're going to assume the spinner has an equally likely chance of landing in any of the 4 zones. There's a probability that you lose $10, as in you have to pay $10, but only if you go in this little spot right here. So that's a negative number. So how do you handle that? You just put in a negative number for that. So what's the probability of this spot? Would you agree it's a 1 in 4 chance you're going to hit that part of the spinner?
Yeah.
Okay. Times the amount you get, negative 10. What's the probability for this part? 1/4 again. Except this time you get $5. I think you get the idea. Do it the rest of the way. And one of those you don't have to even multiply because hopefully you're smart enough to figure out which one that is. And get your expected value for this game. P times A, add them all up. I got 3 point something again. Raise your hand if you got 3 point something again. Okay, good. Kate, what did you think it was? Final answer. If you're not done yet, that's okay.
Yeah,
Okay, keep going. All right. Albright, you got an answer that starts with a 3?
Yeah, 3.75.
I agree with you this time. Raise your hand if you had 3.75. Okay, good. So my question is now, there's no cost for playing this game. On average, you're going to win 3.75. Again, if this is about insurance and you think your company will, on average, make $3.75 every time you do it, should you do it? Yeah, the expected value is positive. Do you get that you want to do things where your expected value is positive? And you don't want to do things when your expected value is negative. All right. So if on average, this was a game at like a fundraiser. It's going to be a really sucky fundraiser game for them because people on average are going to win $3.75. If they don't have to pay anything, they're going to lose lots of money. So let's say you're in charge of the games and you're like, okay, how much should I charge? If you want to actually make money for your fundraiser, you got to charge them like $4, maybe even $5 if they're people are going to be generous. But if you charge $4, a lot of people aren't even going to know that they're getting a bad deal. On average, the people playing would lose 25 cents each time on average, and you'd make a little bit of money for your casino or your charity. So the point I wanted to get here is the person who plays it on average then will lose 25 cents. That means the other people that are running this thing will make 25 cents. So the expected value for the player is negative. The expected value for what's called the house, that's what the casino refers to themselves as, is the house will make that 25 cents. So if it's negative for you, it's positive for the other people. All right. Now we're going to talk about your iPads, and somebody just take a second and try to figure out what is that cost for the district. I want to know for real, how much do they charge you for that deal? If you want to pay for the insurance on the iPad, it costs a certain amount. I'd love for somebody to figure it out. Okay, if there's a way for you to tell on the school's website or something, I'd love to use that real number. In the meantime, I'll use like a placeholder number. Would you agree if all of a sudden you step on your iPad and the thing goes, you're going to be like, oh, crap, it's going to cost money to fix that. And I wonder how much money it's going to cost. All right, let's say the normal cost of fixing the screen is $200. Let's say the cost for insurance, unless somebody figures it out.
I found it.
Oh, sweet. How much is it?
For grades 4 to 12, it's $40 a year.
Awesome. Thank you very much. $40 is the option that you have to buy the school's insurance. Okay. Now we got to figure out, is this a good deal? Well, one thing we don't know is the probability. I'm going to ask you this. You guys have had iPads for a long time. You know, you've had them for like many years. Okay. How many of you have had your iPad screen crack, just you in the room here, in the last 2 years? 1, 2, 3, 4, 5, 6, 7. 7 people. Oh, yours broke twice. That actually could count as 8 then.
Mine has broken 3 times.
Okay, that makes 11.
In total 5.
12. All right. So then that's 12 of you, or 12 fixes over 2 years. So then we're going to change that to 6 fixes per year out of 30 kids. No, 20. I want to make it divisible by 6. We're going to go with 24 kids. 6 fixes out of 24 kids. The reason I made it 6 is because I said over the last 2 years, just to try to make it better data. But then I have to figure it out per year. So I'm calling it 6 fixes per year out of 24 kids. All right. So my question now is, I've given you a probability. I've given you the cost of the insurance, which we use last. The last thing we do is see, my expected value is this, but it costs this, to see if it's a good deal. Let's figure out, in the real world, if the P times A and the other P times A all adds up to an expected value that's positive or not. All right. So there's 2 scenarios. Would you agree you're either going to have your iPad break or not? That's the only 2 things that can happen. Over the next year, your iPad's going to break or it's not going to break. We just figured out the probability it's going to break. It's 6 out of 24. Then what's the probability it's not going to break? Wait. Let's do it as a number out of 24. There you go. 18 out of 24 per chance that it's not going to break. That's the probabilities. Then the amounts. If it breaks, do you get, you're going to save, or it's going to cost you $200. Either you bought the insurance or you didn't. Assume you didn't buy the insurance. Would you agree it's going to cost you $200 if it costs that much to fix the iPad? I could be wrong. I made up that number. I know you could get it for at least $200, maybe less. And now the not is kind of cool, because if it does not break, then how much does that cost you? 0. So I don't have to multiply that part. Now do math. P times A, then add it all up. Negative 50 and then times it by 0 just makes that 0. So overall, the risk to you is $50. If the cost for the insurance is $40, do you get I actually probably should have done this the other way. The way I should have done it is to say, you'll gain $50, but you lose 40 for the cost of the insurance. Overall expected value it's smart for you to buy the insurance. Now, I did use a fairly high number for my cost to repair, cost to fix. But so I'm not trying to sell you these schools insurance. Do you get that it's only $10, which means that it's not like the school is making a ton of money on you or you making a ton of money on them? It's pretty close to the actual cost. And that's how a school should do it. They shouldn't set it up so that they make lots of money on the insurance. They're trying to just kind of like make it an option for you. All right, now, I know that got confusing because of the negative there. But I wanted to make it say, if I bought the warranty, it would be worth $50 because you do have some expenses and it's going to save you that money. And the cost of the insurance always gets subtracted off at the end. So the grand total was positive 10. Therefore, smart to buy, given the scenario I gave you. If the actual cost to fix is only $100, then all of a sudden, it might not be smart. I'll show you. If I change this to cost of 100 to fix, then this would be half as big. It'd be 25. And then this is only worth 25. And then you're paying 40 for it. So then, overall, it would be a negative number. If the cost to fix it is not that high, final answer is negative $15. And therefore, you shouldn't buy it. All depends on the cost to fix it. Okay, that's about the hardest kind of problem that there is. Let's do one more like that. I know you can imagine this scenario, a phone. Almost all of you have a phone, okay? Let's say that your phone provider offers insurance on the phone. It could be Apple, or it could be the company that you have for your insurance, for your cell phone service, like Verizon or whatever. Okay, so here's your scenario. Let's say again, it costs $200 to fix a broken screen on your phone. Let's say that there is a 20% chance it'll break. And I'm not telling you the cost of insurance yet. I'll tell you that at the end. So far, you can figure out the expected value of buying the insurance. You just you don't know the cost yet. You do that at the end. Okay, snap out of it. Thank you. Write those down. Solve that. Use your calculator. Get the answer. Row 6, person 2, that is Chase Rizek. Can you tell me, what are these two things that could happen?
Break or not break?
Yep. B-R-E-A-K, Mr. Server. Okay, or not break. Okay, what if it breaks? What's the probability of that?
0.2.
What's the amount you get or you'd save if it breaks and you bought the insurance?
200.
Yep. Then if it does not break, what's the probability of that?
0.8.
And if it does not break, it doesn't save you anything. There's nothing happens. You get $0. You can't walk up to the phone place and go, hey, my phone didn't break. They're going to be like, so what? What, am I supposed to give you money because your phone didn't break? You get nothing. Then this one is worth something. This one comes out to 0, which is nice. grand total, $40. I would call it, that's what that would be, insurance would be worth. Now, what would you predict Apple would charge you for this? Do you think they would charge you 40? No. They want to make money.
55.
Okay. Say they charge you 55. Apple Care is like 200, but it's more complicated than this because it depends on the program they give you. Some of them even will cover if it's stolen. And then they got to not just fix your phone, they got to give you a whole new phone. I'm not saying they aren't making money. They're for sure making money, but they also have to cover bigger claims than the $200 breakage. They have to cover like the whole phone's toast. All right. So then this one would be negative 15. If the EV comes out negative, you don't want it. You're losing money. Do you get some people would still like to buy the insurance anyway? That's a lifestyle decision. Some people really want to be insured for it. Like, you don't have, that way they don't have to worry about it. They'd rather pay that $55 cost and then not have to worry. Because now if my phone breaks, no big deal, I got coverage. Other people are like, on average, I'm going to lose money. I don't want to do that. So it's still, sometimes it's smart to buy the insurance even if your expected value is negative. It's just mathematically going to lose money on average. And most insurance plans are like that because the insurance company wants to make money. Or in this case, Apple, whoever sells the thing. All right, what is expected value? I want you to just read this for a minute because this is like a really dense, how a textbook would write this out. And there's some symbols in this you may have never seen before. But I hope that you realize it comes down to P times A and they add them all up. This is the super complicated way to say add them all up. This symbol is called a summation. You will learn it in pre-calc. Then this is your P times A. They just call it X instead of A. And look at that, P times A, and then you add them all up. Make sense? Okay, to the next slide. Let's go to this one. Deck of cards. Remember, we will tell you anything you want. If it's a test question on cards, you can ask me, how many cards are there? 52. How many of them are aces? I'll tell you, there's 4. How many kinds of things are there? The clubs, spades, hearts, and diamonds. I'll tell you any of that you want. You win $15 if the card drawn is an ace. P times A. Every time. Probability times the amount. And then we'll just add them up at the end. What's your probability to get an ace? 4 out of 52. What's the amount you get if you get an ace? 15. And then there's another P times A. And then we're going to add them all up. Well, I guess that's the only thing that can happen. No. You either get an ace or what? You don't get an ace. What's the probability of that? 48 out of 52. Times the amount you get if that happens. Yes, -1. You add it all up, and that'll tell you if this is smart or not. Remember, put parentheses around the 4 over 52, and it'll work a lot better. And the 48 over 52 also needs parentheses. You could reduce it, but you don't have to. I did not get that.
Did you do the negative one? Negative.
I put it all in at once on my calculator, so I've got the final answer, and I got like a decimal. It starts with a 2. Anybody else get that?
Yeah, 2307.
2307?
Yeah.
Nice. Now, what's important is that you know does that mean that you should do it or not? Is the expected value positive?
Yes.
Yes, then you should do it. Now all of a sudden, what if they say, oh, but it costs $2 to play? Well, then I'm gonna subtract 2 from that, and I lose negative 1.77 every time I play it. So obviously, if there was a cost to play it, probably not smart, but there's no cost. All right. I think we should get to the end here and get to your homework. So, expected value worksheet. If you would please find the worksheet, open it up. I'll tell you which problems to do and skip. Get started right now. I bet you we'll get it down so over the weekend you only have like 10 minutes of work. That's kind of my dream assignment. Is you get about 10, 15 minutes in class, and if you actually work hard on it, you only have like 10 minutes left for home. Why do I even want you to have homework at home? Because it'll stick better if you revisit this again within the next 24 hours. If the only time you look at it is now, and you don't do anything till Monday, you're gonna forget what we did. If you have 10 more minutes of homework, it's perfect. We'll remind you what's going on. Just zoom in a little bit. Excellent. Okay, so we should do number 1. Okay, and number 2 is number 1, so I'm gonna skip number 2. Number 3.
Yo, check.
When I checked, it was like,
So we'll do that.
I still have it full.
What was it?
It was like the thing is right now, so it's not, so just put it, like we didn't have school guys. But obviously that,
All right, we're gonna do 1 through 5
Two is what? So we're gonna do.
and skip 2.
So just 1, 3, 4, and 5.
1, 3, 4, and 5. That keeps it reasonable. I know some of them have a lot of parts, but you gotta admit, I cut a lot out. Okay, number 1. Yoakum, could you read it to me, please?
A survey was conducted by the Public Housing Authority in a certain community among 1,000 families to determine the distribution of families by size. The results are shown in the table below.
I'm guessing there's gonna be a probability times an amount, and then we're gonna do that a bunch of times, and we're gonna add them all up, okay? And I'm getting it's out of 1,000, that's, so my probability is probably out of 1,000. Okay, so what are the different events that they look at there? The different things that could happen.
Family size, frequency of occurrence.
Okay, so let's look at one event and figure out the probability of that. So like, give me a family size and the probability of that.
2,
That's an amount of 2. And what's the probability of that?
350,
Out of,
1,000.
there you go. You get what I just did there? This one isn't about money. This is about an amount of, not money, it's an amount of kids. All right? Give me another amount of kids that different families have. Look on the chart. Okay, but wait, what's the amount of kids in this one you're doing now? It used to be 2. Let's do like 3 kids. Do they have a 3 kids option? Okay. Then what's the probability of that?
200 out of 1,000.
I knew it was going to be times P times A, and then I'm going to add them all up. I bet there's another amount of family. Did they like lump them all together like 4, 5, 6, 7, or did in one clump, or did they have separate ones for each?
Like separate ones for each.
Okay, then we got to keep going. And was there a single kid option?
No.
Okay. 2, 3. What's the next one? Is it 4? I would assume.
Yeah.
Okay.
245 out of 1,000.
Was there a 5 kid option?
Yeah.
What's that one?
125 out of 1,000.
is there a 6-kid option?
Yeah,
Keep going then.
66 out of 1,000.
And was there a 7-kid option?
Yeah, 10 out of 1,000.
Please tell me that's the last one.
There's 8,
Ugh.
4.
How about the 8-kid option?
4 out of 1,000.
I do know a family that's got 12 kids. Okay, what's the, wait, 6, 7, 8, is that the end? 8 kids is the last one? Okay. All right. It's probably a good time to mention that in the real world, we do have some families that have that many kids, and it's a good thing. Because I know this is still controversial because some people don't know the latest trends, but the latest trends is that we don't have enough kids being born to replace our population. And what that means is, in some countries, in 20 years, they're going to have half as many people in their country. Now think about it. Think about what that means. If there's half as many people in the country, like right now, let's talk about the U.S. Let's say that happened in the U.S. That there's half as many people in the U.S. 20 years from now. If that happened, do you get there to be a ton of houses that are empty?
Yeah.
Because those people were living somewhere. You see what I mean? You see how that could be really tragic for a country if half of their houses are sitting empty? That's already happening in China. They have tons of empty houses. Hundreds of thousands, millions of empty houses in China. And it's going to happen in other countries throughout the world. Japan has got it the worst. They started this first. They had a low birth replacement rate. So anyway, bottom line is that there's a staggering number of countries that are going to be shrinking over time. And that's going to really make some difficult challenges. All right, and I am not going to do all of this. You can multiply those all out, and you have a key, and I think you got the idea. And that's all I have for you for today.